Okay, let's begin with question number 11. Okay, so let's move this question on the whiteboard, please. And we shall begin. Okay, the diagram shows part of a curve. Y equals to 2x minus 6. All right, over x plus 2. Crossing the x-axis at P and the y-axis at Q. The normal to the curve at P, there's a normal here, means it's a 90 degree here. Yeah? Good to indicate that. Meets a tangential 90 degree toward the tangent line. So wondering what it means, something like this. The tangent line there, 90 degrees towards that. Huh? Okay, and then meets the y-axis at R. So given that dy dx is like that, find the value of k first. Okay, this is just application of the quotient rule, right? Okay, let's say we just let this equals to u over v, where u is 2x minus 6, comma, v is x plus 2. Let's differentiate, please. Du dx equals to 2, and dv dx equals to 1. Okay, then we use the quotient rule. The rule tells me that when you can write it like this, so dy dx, when something is divided, v du dx, that order, denominator first, minus u, dv dx, whole thing over v square. Okay, let's substitute, please. So the v is x plus 2, du dx is 2, minus u, the u is 2x minus 6. Just copy and match the values that you calculated above, please, like that. And then this is x plus 2, whole thing square. Please do not expand the square, huh? Always leave it like that, as you see it. Denominator trick. Okay, now you'll know. Then multiply. Remember, expansion of brackets, just normal algebra. So multiply here. Then the negative sign, you multiply like that. So what does the numerator become? 2x plus 4 here, minus 2x plus 6. Then whole thing over x plus 2 square. So the whole thing is x plus 2 square. You can easily see that, this thing is cancelling out. What is cancelling out? The 2x. Ta-da! 2x cancels out. 4 plus 6, so 10 over x plus 2 square. So we compare it with the given one. What is given here? It's given that this one like that. So k over x plus 2 square, because this is dy dx. So therefore, we can easily see that by comparing the numerator, because the denominator is the same, that's why we can do that. So k is equals to 10. Okay, now we need to find the length of RQ. Okay, let me just clear this and put k equal to 10. We might use it. K equals to 10, yeah. Okay, let's do the last part for today. Huh? Let's do the RQ part. So the length of RQ is not a curved line. It's quite obvious that it's just a straight line here. Just mark it blue from here to here. So we just need the coordinates accordingly. So let's try to find the coordinate of Q. For Q, this is an y-intercept. Q is y-intercept. Y-intercept means we put x equal to 0. So when you put x equal to 0, this one, y equals to 2. This one is 0 minus 6 over 0 plus 2. Okay, 0 minus 6 over 0 plus 2. Okay, so y equals to a negative 6 over 2. So y equals to negative 3. So y equals to negative 3. Okay, that's what it means. So that means the coordinate of Q is easily found as 0, negative 3. So please take note. I'm going to mark this as negative 3. This is the meaning of the Q here. Okay, so we understand really something. Okay, now let's go for, so we got an idea that we must find the coordinate of R likewise. It's an y-intercept. Huh? So imagine a tangent line goes through like this. Remember, it's not a tangent there. So let's redraw it. This is a normal. So the gradient of this tangent line is at P. So but it cuts the x-axis at P. So that means if x-axis How do you find the x-axis, x-intercept? So put y equals to 0 now. Okay, let's put y equal to 0 on this curve equation. So 2x minus 6 over x plus 2 is 0, as you can see from here. So only numerator can be 0. So 2x minus 6 is 0. Solving it, which we get x equals to 3. So you got x equal to 3 means here the x value is 3. What's the use of this x value? So when we evaluate the dy dx at x equals to 3, what happens? Remember the 10 over this one, this expression? It is now actually 10 over x plus 2 square, whole thing square. So 10 over, replace the x with 3 plus 2 whole thing square. Oh, 25. 3 plus 2 square. So divided by 5 is 2. Divided by 5 is 5. 2 over 5. This is the gradient of tangent. Okay, this is the gradient for the tangent. So gradient of the tangent means, so we need to remember that 2 over 5 multiplied by the gradient of the normal, let's say m, it will be -1 because tangent and normals are perpendicular to each other, from which we can deduce that -1 times 5 over 2, it becomes -5 over 2. So this is the gradient of the normal line that we're talking about. Oh, this is the gradient of normal. So if the gradient of normal, is, aha, we found the gradient already. So we also know a point, not just m, we know the gradient normal also goes to the point 3, 0. Oh, so we got 2 points. We can find the equation of the line y equals mx plus c. Let's try that loose. So equation of PR or RP, doesn't matter, it's the normal line. Y equals to mx plus c, with the m just we found is -5 over 2, but we have to substitute to find the value of c. The c means the xy, use the coordinate of p as xy like that. So 0 equals to -5 over 2, which is the m. X is 3, plus c. Aha, so it becomes plus c like that. So then we solve that to get c equals to, -15. So 15 over 2. Okay, 15 over 2. So this is the value of c. All right, no worries. So this is so then when we have the equation, now we can write it as y equals to mx, -5 over 2x, plus 15 over 2. Okay, 15 over 2 is the y-intercept, and also we can just mark it here 15 over 2 at the top like that. So being that said, now what is this 15 over 2 is just distance, and what is the -3 is just like 3 downward like that. So we can easily deduce now the final part, which is the length of RQ is equals to OR plus OQ. Okay, OR is what? The gray blue number, 15 over 2. What is OQ? Below the x-axis, we're taking distance, so we ignore the negative sign, plus 3, from which we can deduce the final answer to be 10.5 units. Thank you.